Okay, here we have question 10, section 6.3, question 8, section 6.3. The table shows the hours of daylight. So these are the days of the year. So this is the 15th day, or halfway through January, the 46th day, or sort of into February, and then how many hours of daylight. So January 15th had 8.5 hours of daylight. What is that, February 15th actually had 10.1 hours of daylight, and so on and so forth. So the X's are the days of the year, and the Y's are the hours of sunlight. And so if you look at this graph, you need to be able to interpret what these numbers mean that we got from Desmos. So the first one we're going to look at is the equation of the axis of symmetry. And that equation is y equals 7. You see it there. And that equation, which I would love to make a different... Oh, that's not a good... There we go. Okay. Let's go with black. Sure. So that equation is, if you look at the picture, this is the only part of the graph that we care about in the real life aspect. This is sort of just math world. You're never going to have negative hours of light. It's just, this is not interesting. So looking at our half a graph we have here, because one up and one down is a full cycle, in this half a graph, that equation of the axis of symmetry, we have to just think about what this is. This is really the lowest value of sunlight this place is ever going to get. It's saying that on January 1st, it should be about 7 hours of daylight. That's what this says. And the beginning and sort of end of this is there. So in this case, the axis of symmetry is actually the smallest amount of sunlight they're going to get in Regina. Now, if we want to talk about the period, we could think about x equals 720, which is the period. That's way over here, and that part of the graph is pointless. It's not doing anything. In fact, half of a period, which is 360, that's where our graph sort of stops. That's all we care about in real life. And so that's telling us that there's about 360 days in our graph, which, yes, there is about 360 days in a year. And since X is the number of days, one would hope that that would finish off at around 360 or 365 would be even better. And there's some decimals that would get us closer to 365. So the period here doesn't mean anything, but half of a period is 1 year. Then we're looking at, so that's the period, the axis of symmetry, and now we have the amplitude. So in this case, the amplitude is simply the smallest value up to the biggest value should be a distance of 9. So the least sunlight to the most sunlight should be 9. So we scroll down here, the least sunlight is about an 8, the most sunlight is a 17, and the difference between those is 9. So this is accurate. This is saying that from the smallest to the biggest is 9, and this is saying that the smallest is around 7 on January 1st, and that's kind of saying nothing, but half of that is saying that that's when our graph works, at the days of the year that it works. Now, just to finish, if I change this to cosine, you actually end up with a nicer graph. You get a different set of values, and you get a more perfect graph, but that's something we can talk about a little bit later